Hello again, and welcome to our what are we up to? Third video now on the topic of algebra and linear equations. Look, this will be the last video that I record before we end up beginning this topic on Monday, once I've gotten back from camp. Now, unfortunately, between these first three videos, I haven't had the opportunity to take note of any improvements you'd like made or any suggestions that you thought would help your learning once we start getting into this flipped learning. So make sure that if you're listening to this video and you haven't yet expressed any concerns or ideas that you'd like to have change between now and when I start recording again, please make sure you come into school the next day and we'll see what we can do. Anyway, hopefully by now you will have received your booklets on this particular topic. Hopefully also you've been going back and filling them in with the answers to the example questions that we're doing, just like we would normally be doing in class. Don't forget, after each video when you come back in, we will be having a small quiz based on the stuff that you have seen, just so I can make sure that you guys are keeping in touch with what's going on. Alright, so exercise 2C. This was all about expanding and factorising. Now, if we have a look, we've done this so many times before, but we just need to make sure that we revise and can remember exactly what we can do. For expanding, this is just where we end up multiplying the brackets out. For example, here we have 2 and in brackets we have a plus 3. To expand, what we need to do is take the number which is outside the brackets, this number 2 here, and we are going to multiply it by not only the first term, which is the letter A, but also the second term, which is the number 3. The point here is not to forget to first multiply it by the A, but also the 3. In many a question that I've seen, some people will just go 2 times A and then leave the 3 by itself. When we expand, we must multiply by both terms. Alright, now what that means is if we have a look at the example here, so we take the number 2 and we multiply it here by the first term A. Hopefully by now you should know that 2 multiplied by the letter A is just 2A. Then we take the number 2 at the front and we multiply it by the second term, and 2 times 3 is 6. Remember that this sign here, the addition sign which sits between the A and the 3, automatically moves down and separates the two terms once we've expanded them as well. Another way to think about it is you're going 2 times positive 3, which gives you positive 6. There's two ways to think about it. Alright, with factorising, that's pretty much the reverse of expanding. You're taking your expression and you're finding the common factor between both of your terms, taking that outside and putting the leftovers back inside the brackets. Now this is just the same example but in reverse. Now with an expression, you can have a common factor of numbers and letters. In this example, the common factor between both of these terms is just the number 2. Now, if this had the letter A beside it as well, we could take out a common factor of A, but it doesn't, so the common factor remains as being the number 2. Remember, a common factor is simply just a number that can be divisible into both the first term and the second term. Now obviously with this example here we've got the common factor of 2. Now 2 is easily divisible into 2A and it's also divisible into the number 6. Now what happens is once we've taken out the common factor, it's the equivalent of dividing both of these terms by that common factor. And once you have divided both of these terms by that common factor, this is what remains, these leftovers. If you divide 2A by the number 2, so 2A, if we divide that by the number 2, we end up just getting the letter A, which is our first leftover up here. If we divide 6 by the common factor of 2, we get the number 3, which is our second leftover. So you take each term, divide it by the common factor, and put the leftovers inside the brackets. That is how we factorise. Now I'll show you a bit more in detail a little bit later when we get to example number 3, but for now let's just have a look at the few examples that we have at the top of your page. First of all, let's have a look at example number 1. So in this example we are going to be expanding the brackets. So we're going to take the number that's on the outside and multiply it by everything that's on the inside. Now, here's our first term, here's 3, and we're going to multiply it by our first guy inside the bracket, which gives us 3a. Then we're going to take 3 and multiply it by our second term, which is the 5, and 3 times 5 is just 15. And that's our final answer. There's no more working out required. Okay, moving on to the second one. This time, the figure outside the brackets is a pronumeral, but the method still stands. So we're going to take our pronumeral m and multiply it by first the p and then the q. Alright, so m times p is just mp, and then we are going to subtract. This is our operation in the middle, subtract m times q, which is just mq. So our final answer is MP minus MQ. Simple. Alright, 1C. Again, all we're going to be doing is taking the term outside the brackets and multiply it by both of the terms inside the brackets. So 3a times 2m, let's deal with the numbers first. So 3 times 2 is 6, and a times m is just am. Now this is just taking you back to a couple of the techniques that we learned in the first couple of exercises, remembering how to multiply our terms together. Okay, here is 3a, and we're going to multiply it by 5n, remembering to keep this minus sign in between, minus. So 3 times 5, doing the numbers first again, is 15, and then putting the letters at the end, a times n is an. Alright, last one. This is going to be a little bit more tricky because we have a minus sign at the front. Now we have to keep that in mind when we are multiplying it out. So negative 4 times 3 is negative 12. Remember, that negative sign does not get used up in the first term. We need to continue using this negative sign when we multiply our second term. So minus 4 multiplied by 4a is minus 16a. Did you see anything that I forgot? This sign here, I forgot to put that in. So we'll put that in now. Now technically you could leave your answer like this and this would be correct. However, to simplify this down to our best answer, we know that two negative signs together create a plus. So our final answer is going to be minus 12 plus 16a. Now of course you didn't really need to do this step. If you recognize that the two negatives would have cancelled out to make a plus sign, you could have immediately gone down to this answer here. But for now, this is just showing you how we get from here, from here across to here and to our final answer. Alright, let's do a little bit harder expanding. Example number 2. For these types of questions, what I like to do is to separate the question into two parts, as if this was a question here, and then this was a question here. And then what I'm going to do at the end, once I have finished answering both of these separately, is to add them together. Now, if you feel confident that you can do it in one go, that's fine, but let's just separate it into two parts for now. Alright, so here is our 2a plus 7. If we expanded that, that's going to be 2a, and then plus 2 times 7, which is 14. Alright, now let's leave that for a moment, and over in this space over here, let's expand our second part of the question. Alright, so this is 3a plus 2, which if we expand is going to be 3 times a, which is 3a, And then over here we've got 3 times 2, which is plus 6. Now remember, what we're going to be doing is simply adding these two expressions together. Even though this was one big expression over here, we've separated it into two pieces, and now we're going to join them back together again. Alright, so 2a plus 3a is 5a, and 14 plus 6 is 20. So our final answer is 5a plus 20. See how it's a little bit easier? While written in the question over here, it looks long and complicated, but if we simply just split it into two separate questions, it's a lot easier to work out. Alright, let's have a look at this second one and see how we go. Remember, we're going to split the two sections. So first we're going to deal with the 3g, g plus 5. Then we're going to deal with the 5, 2g minus 3, and then we're going to subtract them from each other. Okay, expanding this one out first, the 3g. 3g times g is 3g squared. 3g times 5 is 15g. Alright, now we'll leave that for now. Come back to it. First, let's expand our second half. So 5 times 2g is 10g. 5 times 3, remember the minus sign in the middle, is going to be minus 15. Alright, now that we've got our two things together, we are going to have to subtract this left hand side from the right hand side. Okay, 3g squared, well, we can't take anything away from there, so that's just going to remain as 3g squared. Okay, 15g, take away 10g is going to be 5g. And then we've got no numbers over here, but we are going to be subtracting negative 15. So we're taking away a negative 15. So that's going to turn into plus 15, like so. Alright, and that's our final answer. 3g squared plus 5g plus 15. Does that remind you, does this expression remind you of anything in particular? Hopefully it does. Remember, we did a whole chapter on this last year. Okay, our final example before we can head off. This time, instead of expanding, we're going to be factorising. And remember, to do that, we need to be finding a common factor between each of these terms, which could be a letter, a number, or maybe even both. In this example 3a, if we have a look, there's only a letter in the first term, so we can't have a common letter as it only exists in the first term. So looking at our numbers then, what do you think is a common factor between 9 and 12? Hopefully you can remember that a common factor between 9 and 12 is the number 3, which is what we're going to be putting out the front of our brackets. Now once we've found our common factor, we are going to be putting the leftovers inside the bracket. Remember, to do that, we simply divide both terms by our common factor. So 9m, taking out a common factor of 3, leaves us with 3m. Then we take this minus sign and put it inside the bracket as well. Remember, we're just doing the opposite of expanding. And then finally, taking out a common factor of 3 from 12 leaves us with 4. Now if you want to check to see if you've got the right answer, all you need to do is just do the reverse. Expand it out by multiplying both of these terms by the number 3, and you should end up with the question that you started with. So 3 times 3m is 9m, and 3 times 4 is 12 with the minus in the middle. So that gives us 9m minus 12. So we're good. Alright, next example. Now, if we have a look at the numbers first, we know that the first one is 25 and the next one is 15. What's in common between those two numbers? What can be easily divided into both 25 and 15? Well, hopefully you know that that's going to be the number 5. Now, before we rush to put our leftovers inside the brackets, do we have any common letters? If you look, we have a to the power of 8 and a to the power of 6 here. That means we have both a common letter, the letter A. So we're going to put the letter A out here. But not only that, if we have a look, we've got a to the power of 8 here and a to the power of 6, which means we can put more than just one a out the front. How many are we going to put out the front? Well, in fact, we are going to be putting out 6. We can take 6 out the front, and what that's going to do, once we have a look in our leftovers, if we take 5 away, or not taking 5 away, if we take out the common factor of 5 from 25, we're left with 5. Now remember, if we've got our common factor of a to the power of 6, remember back to your index laws, what happens when we do a to the power of 8 and we're going to take out a common factor, or in other words divide by a to the power of 6. What happens there? Well, we subtract the two powers and we're left with a squared. So inside we're going to also be left with a squared. Alright, then adding on, moving this symbol into the center, taking a common factor of 5 out from the number 15, we're left with 3. And then we took out a factor of a to the power of 6, which means that it's this a to the power of 6 here is going to be gone. So it's just going to be 3, the leftovers of 3. Now again, if you wanted to check, you could multiply it or expand the brackets out and you will get this question again. Remember, if you have any questions, please make sure you come and check in class before we get started. Okay, next example. Minus 4d plus 28. Now what number goes into both 4 and 28? That's right, it's the number 4. Now in mathematics, what we like to do, if we have a look at the previous example in number 1, see how in 1d we put the negative numbers out the front, and even though we had a minus sign in between our two terms, the common factor that we took out was actually a negative number. So if we go back to number 3, you'll notice that if we can take 4 out of both 4 and 28, what we're going to do is actually we're going to take out minus 4 at the front and leave the negative outside the bracket. Now if we have a look at the numbers, we've done that now. Now the letters, we've only got 1d but nothing over here, so we can't take any letters at the front. So let's see what our leftovers are. We've taken minus 4 out the front, which means that all that's left over of our first term is the letter D. Then having a look at positive 28, if we're taking out a negative factor, that means that this is no longer going to be positive 28, but in fact, when we take out negative 4, we're going to be left with minus 7. Now the reason this changes from positive to a negative is when we expand it, the negative out the front will combine with the negative outside to give us positive 28. If we'd left it as a plus instead of a minus, when we expanded we would have got a negative sign in the middle. Okay, final one. In this example we have no numbers. That means there are no common factors with our numbers, but in each of these two terms you'll notice that there is the letter E, and we can take that out the front. Now like in example 3b, we need to make sure that we take out the most letter E's out the front. So we didn't just stop with 5a, we took out 5a to the power of 6. And the same goes with this question here. We're going to take out E, but can we take out more than just the letter E? Can we take out E squared or E cubed? Now if we have a look at both of these, the highest number is the number 2 and the lowest is the number 1. If you notice, going back to this example up here, we took out the lowest number, a to the power of 6. And since the lowest power of this example is e to the power of 1, we have to keep it like that. Alright, so we take out a common factor of e. Now what happens if we take out a common factor of e from our first term? Looking back to our last example up in b, we notice that we subtract the powers. So this is just going to be e and then minus 1, because we take an e out and all that's left with is the number 1. Now if you expand that back out, choose a different colour, e times e is e squared, and e times 1 is e. So we get back to our question. Alright, and that's it. These are the questions that we're having a look at today. I hope you've enjoyed listening to our third video in this series, and once again I'd encourage you to come into class tomorrow, and if you have any suggestions or questions or anything like that of stuff that you'd like to change, to let me know as soon as possible. Anyway, hope you have a good evening, and I'll see you tomorrow.